Hello friends, so in this video we are going to learn about how we can delete the last node of a circular linked list. Right? We already have seen how we can delete the first node of a circular linked list. Now we are going to see about how we can delete the last node from a circular linked list. So we already know that the last node of a circular singly linked list points to the first node of the linked list, right? So let's say we have four nodes in this linked list. Our head is there pointing onto the very first node. Let's say the data are 10, 20, 30, and 40, and the first node contains the address of the second node contains the address of the third node, and so on. And I guess you already know what would be the address here. Of course, the 100. Okay, because it points to the first node. Right? Now we have to delete the last node from this linked list. Right? So we need to traverse, of course, there should be a pointer traversing till the last node of the linked list. Okay, so if we reach at the last node, what we need to do, we need to we need to delete this part, and we need to update the pointer of the last before node pointing on to the first node. Okay, why we need to do that? Because the last node of a circular singly linked list always points to the first node, right? But if we reach here, we won't have a pointer pointing back to this node, right? Because we are on this node, we can't point back to here. Okay, so that is why we may need one more pointer, p, let's say p, so that q is always ahead of p, and p points just one node back to q, and so that when we have p here and we have q here, so we can update the next of p as the head. Okay, so that is why it is needed. So you can just guess from the diagram why I am drawing every time the diagram, so that while before writing onto any function or any code or any algorithm, we need to analyze the situation, we need to analyze what we are going to do, how we are going to do, using this example, right? So here we can easily guess that one pointer we need to point to the last node, because we have to delete this node, and one pointer we need to point to the last before node, because here we need to update the address of the first node. Okay, and we can't make use of only this, because this will never come back here. Once we have moved on, the address is gone, because we can only move in one direction in singly linked list. We are next going to see about doubly linked list or doubly circular linked list, where we are gonna have two pointers, but here we are left with no choices. Okay, so let's see. So let's have this function, right? Delete at end single circular linked list. Here we are gonna provide the node pointer head to this. Okay, now we need to have two pointers, node pointer p, and of course node pointer q. For that reason, we need to check if the head equal to null, that is there are no node in the linked list. We need to print f that the list is empty. Okay, we need to print this, that the our list is empty. Okay, if there are no nodes in the linked list, right? Now else if, what we are going to see, we are going to see the next of head equal to head, that is there is only one node in the linked list. Okay, in that case, what we are going to do, when there is only one node in the linked list, we are going to delete it, right? Of course. So we are going to free the head, and we are going to update the head to null, right? But let's say we have two or more than two node in the linked list, then We need to have the P pointing to head, and we need to have the Q pointing to head initially, and while the next of Q not equal to head, right? So while the next of Q not equal to head, P equal to Q and Q equal to next of Q. Okay, so we are doing this. Why? For example, this is a linked list. I'm demonstrating here only a four node linked list. This points to this, right? So if initially P and Q both are pointing to this because both are assigned to the head value, then we are checking while Q next not equal to head. So next of Q not equal to head. So we are assigning P to Q, that is P is pointing here and Q equal to next of Q, right? Again we are checking the next of Q not equal to head. So the next of Q not equal to head, then what we are doing, we are assigning P to Q. So P is now pointing to here and Q is moving to next of Q. Again we are checking the next of Q not equal to head, then it's true. Then what we are doing, we are assigning P to here and we are moving Q to here. Okay, now we are checking the next of Q not equal to head. Oh shit. Next of Q is equal to head here because this points to this. Okay. So now our Q is here and our P is here. So this condition will fail here when the Q reaches the last node and P is initially at this position. So we'll come out of this loop, and then what we'll do, we have this P here, we have this Q here. So we are doing what? In the next of P, we are placing the head and we are freeing up Q. Okay, we are freeing up Q, that is this is gone, deallocating Q, that is this is gone, and P next points to this node, right? And after all this, P is assigned to null, Q is assigned to null. Okay, this way we are deleting the last node of the linked list. So is that clear? Okay, then we are going to see about double linked list or two-way linked list next. So till that, goodbye. Keep watching. Thank you very much.